Okay, for our next section, we're going to be talking about the tidyverse and tidytext. If you're not familiar with the tidyverse, it's a collection of R packages specifically designed for data analysis. All these packages kind of have an underlying design philosophy that they follow, and the principles that are part of this underlying philosophy are pretty simple. One, they use function names that are descriptive. So it makes a lot of sense when you're using something like dplyr and you see the function name summarized, that it's going to summarize things for you. They also focus on verbs. Like I just said, summarize, but they also have verbs like arrange, etc., just for general methodologies. They do also include verb-noun pairs, so it's not just a verb. And importantly, these names are as self-documenting as possible, so it's very easy to reference them. When you run tidyverse functions, they should not return a novel data structure. So there is one basic data structure that all tidyverse data frames are going to follow, and all functions are going to return data in that structure. Once you have a data frame up and running, it's relatively easy to add new columns, and that can be done without affecting the class of the data that's already existing in the data frame. How this is going to happen for us is generally we're going to get words per text, and then we're going to create columns that relate to those words in the text. There is some loss of computational performance because the data frames are so rigidly structured. But that's okay because we're not going to be working with really large samples. And then, of course, data frame is the preferred structure for tidyverse and tidymodel packages. So we're going to be using tidytext. And as with the tidyverse, the purpose of tidytext is just to make text analytics as easy as possible and effective, and have it follow all of the kind of design philosophies that you find in tidyverse. So tidytext, like tidyverse, is going to use a data frame structure where within that data frame, each variable is going to be a column and each observation is going to be a word. In our case, the observation could be words or texts. It can also be phrases or sentences or paragraphs. And then those columns in the end for us are going to be linguistic features that we're interested in. So the tidytext format is a table with one token per row. And that token within tidytext is going to usually be a word, but as I mentioned before, it can also be n-grams, sentences, or paragraphs. We will then take those words, recompile them into text within the tidyverse framework to get overall understanding of linguistic features within texts. There are a lot of other R packages that do more advanced text analytics than tidytext. If you're interested, there's actually a way to use Spacey in tidytext. Or in R, sorry. And Spacey will allow you to do part of speech tagging. It will allow you to do semantic similarity with word2vec. There's even a transformers module in it. It will also allow you to do named entity recognition and a variety of other features. There's also two other packages called TM and Quantita. Those both allow you to do part of speech tagging, dependency parsing as well. But we're going to be using tidytext. So let's look over the tidytext pipeline. Starting over here on the left, you're going to have that text data. As I mentioned before, that text data is going to be well-structured data that's going to be consisting of UTF or simple Unicode character features. Within that, tidytext is going to use something called unnest_tokens, and that's going to basically tokenize each single word within that text and put it into a tidyverse data frame. And then within that tidytext data frame, you can call things like dplyr or tidyr to do things like counting and frequencies. And then you can kind of summarize within that data frame features like the number of content words, number of stop words, frequency of words. And then you can use R packages like ggplot to visualize it. So that's tidytext, part of the tidyverse, and that's what we're going to be using throughout the rest of this module. And we're going to talk a little bit about the class data set next.